This video will cover work, force, power, and efficiency as it applies to typical physical science problems. We will begin with work. The formula for work is force times distance. Now, these are typical physical science problems, meaning that the problem will be set up in word form. Two of the three components will be stated in the word problem. The third will need to be solved for. This will require basic algebraic skills. How much work is performed if you apply 85 newtons of force on a box causing it to move 3 meters? Now, the key thing for understanding these problems is to understand what unit each of the components of the equation are in. Force will be measured in newtons, distance will be meters or kilometers, and work will be measured in Newton meters or joules. To solve this problem, we would take 85 times 3 and we would have 255 Newton meters, which is the same thing as a joule. Next problem. How much work is performed if you apply 37 newtons of force and move a wagon 4.3 meters? Remember, work equals force times distance. Our force is 37 newtons. Our distance is 4.3 meters. We do the math and we get 159.1 Newton meters or 159.1 joules. Final problem. How much work is performed if you apply 118 newtons of force on a car that is stuck in mud and does not move? Now, while you are pushing on this car with all of the force you can, because distance is 0, 118 times 0 is 0. So you may be tired from pushing the car, but no work is performed. Now we will take that same formula, work equals force times distance, and this time we will solve for force. How much force was required to move an object 3 meters if the joules were 75 joules of work and the distance was 3 meters? So we will use the formula work equals force times distance. We need to solve for work, so we will place 75 joules equals x times 3 meters, and when we solve for x, we will get 75 divided by 3. We will get our force, and we will have a force of 25 newtons. Now notice that the meters canceled out. Here we will be looking at power. Now the formula for power is work divided by time. Many times when we are given a formula such as power equals work divided by time, we are not given the work. We will have to go back and look at work's formula being force times distance. Now as we look at this problem, we have a figure skater that lifts his partner. The partner weighs 450 newtons. He lifts the partner 1 meter in 3 seconds. How much power is required? The first thing we need to do is take our force and our distance, and we need to work that out to get our work. So work equals force times distance. So 450 times 1.5, we would get 675 joules. Now that we have the work, we can apply that to the formula power equals work divided by time. We have a time of 3 seconds. So 675 joules divided by 3 seconds, we get 225. The units would be watts. So the formula for power is work divided by time. However, many times work will not be stated in a problem. We will be given force and distance instead. So note that power can equal force times distance divided by time if work is not given. If work is given, power equals work divided by time. So do be aware of the two equations. Work input is the work that is done on a machine, and the formula for work input is the effort force times the effort distance. Work output is the work that is done by the machine, so work output equals the resistant force times the resistant distance. Because of friction, our work output can never be larger than our work input. Now, while machines make work easier, they do not multiply work, they only multiply the force. So work output can never be greater than work input. Therefore, efficiency is an equality that is often looked at with regard to work. How efficient is a machine taking the work input and converting it to work output? The higher the efficiency, the better the machine works and the less energy that is lost within the machine. So the conservation of energy states that we can never get more work out than we put in. Our trade-off between this is force and distance. So with regard to efficiency, we will measure how complete work input is converted to work output. The formula for efficiency is work output divided by work input times 100%. Efficiency will be given in regards to percentage. It will always be less than 100% due to energy and work being lost due to friction. So let's examine an efficiency problem. A worker exerts a force of 500 newtons to push a 1500 newton sofa 4 meters along a ramp that is 1 meter high. What is the ramp's efficiency? Remember that efficiency is work output divided by work input times 100. Now before we begin the problem, let's identify the components of our problem. Our effort force is 500 newtons because the worker is exerting a force of 500 newtons. The effort distance is 4 meters because the worker pushed the sofa 4 meters along the ramp. The resistant force is the weight of the sofa. In this case, it's 1500 newtons. The resistant distance is the ramp being 1 meter high. Now here we have this diagrammed out, and many times diagrams are helpful. So we have our effort force, our effort distance, our resistant force, our resistant distance. So we will calculate our effort work or work input. 500 newtons times 4 meters, we will get 200 joules. Our work output, 1500 newtons times 1, and we get 1500 joules. To calculate our efficiency, we will take our work output, divide it by our work input, 1500 joules divided by 2000 joules. We will multiply that times 100%, and we will get an efficiency of 75%. So the question now is the 75% efficiency of the machine high enough for that particular problem? In an ideal machine, work input equals work output, but in the real world, some energy is lost as friction. Therefore, work output will always be less than work input. The question that arises is, what is an acceptable efficiency? And that would be something that each engineer would have to answer for each individual circumstance.